12.
Concept 12, that is correct. Ebony, can you hit one of the lights, please?
I need to. Where did you think?
Right? Concept 12 you see on the list as function notation. I added the word and evaluation of the words, okay? So we are looking at what functions, how they are written. God bless you, Carl. And we are looking at the value of a function.
You called her Caroline?
Carol.
Caroline.
Oh, I didn't. I've called her other names before, not Carol. I screwed that one up, but never Caroline.
Oh, I just really.
What happened?
I thought you called her Caroline, which would actually be funny.
Carol. Okay. If we think about functions, guys, we think about input and output. Now, we want to write them in some sort of notation. So the first thing we say, we start with this. Has anybody seen something like this before?
FX.
FX. What does that mean now? Like the TV channel FX? Fair enough, fair enough. Now, what this means in terms of using our English correctly, this is function of x. Okay? This means it's a function of x. That's all it is. Now, it is traditional to use f of x. You could use g of x. You could use h of x. You could use k of x. You could use m of x. It does not matter. Again, it does not matter. Now, f of x is also another way of saying y equals. You know, you've always seen like y equals mx plus b, or y equals ax squared plus bx plus c for quadratics. Same idea. So f of x, g of x, k of x, those are just the y value. Again, it is important to know that, because later on we're going to talk about this, we're going to make a correlation, that these are the same. Again, f of x and y, we're talking about the y value or the dependent variable. Remember that the y value is only the dependent variable because it's on the vertical axis. Now, if we were to write some sort of function here like, I don't know, 2 plus 3x to the fourth minus 5x. This tells us that this function can be defined by looking at this expression here. Again, this function of f is defined by this expression. If we want to find the value of y, or the value of, f of x, we simply have to pick a value for x, plug it in, and get our value for y. And we've done this before. You've done this in Algebra 1, you've done this in geometry already. So if you wanted to know, like if you wanted to look at a point, say the point 2, and you were making a table here, you would take the point 2, you would plug in the 2 right here and right here. Okay, once you plug in the 2 there, you're going to end up with 2 to the fourth. That'll be 16 times 3 is 48, minus 10 is 38, plus 2 is 40. So after plugging in a 2, in those two spots, you'll get a value of 40. So when you plug in a value, what comes out is the output, or the y value. Again, you put the input in, you put the output is what comes out. What's up? Are you doing early? Make sure you watch the video tonight, okay? All right, continuing. Again, if you want to know what the y value is, you simply plug in for x. So every time we plug something in for x, we are getting out the y value. Okay, the y value. Now, if I were to graph this, have a good day, Ebony. If I were to graph this point, and I want to graph the point 240, I go over 2, and I go up 40. Again, I go over 2, and I go up 40. Is that clear? We know how to plot simply one point. Now, what does that tell me about this? This tells me the following. The 2 really represents the width of the function.
You said you went up to and over 40.
Over 2, up 40.
Oh.
Again, it's always x and then y.
Oh, I thought that's what you said.
Maybe I said it backwards, sorry. Over 2, up 40. So the 2 is representative of the width. What would the 40 be representative of then?
Length.
The length or the, let's use the word height in this case. Because we've thought about height as the vertical direction. So whenever you're asked for the y value, you could also be asked, what is the height of the function? If they're asked, what is the height of the function, they are asking you for this value right here. The height is 40. When is the height 40? When x equals 2. Again, these are ways that you need to be able to describe what we're going to be doing in this lesson. So when is the height 40? The height is 40 when x is 2. So a problem might say, find the height when x is 5. What does that mean? It means plug a 5 in here, see what you get out for y. Again, find the height when x is 10. Plug a 10 in for x. What comes out to be y? Okay? So this is what we're going to talk about today, is notation. Now, you've seen several of these before, and you've called them certain names. Let's discuss them real quick. If you have some function of x equaling a constant, for example, like 5. Okay, so let's say the function f is defined by just the number 5. This means that at all points in time, the height is 5. Well, how would I graph this if everything was 5? The height is always 5. So at 0, the height is 5. At 1, the height is 5. Very good, Marcus. Very good. So again, this function means that the height, again, we said that f of x is the height, is always going to be just 5. There is no x value in here anymore. So I can't even plug in an x. So if the height is always 5, and I connect all these dots, what do I get, like Marcus said? A horizontal line. Okay? We also call this a constant function. It is important to know the terminology. Please write it down. It is a constant function because it does not change. Think about it. If something is constant in your life, it is not changing, as opposed to something that is dynamic. Dynamic means that there is some sort of change in it. So if you are constantly getting up at 6:15, it means every day you're getting up at 6:15. That's what a constant means. You're repeating it over and over. If you change the time you get up in the morning, your wake-up time is then dynamic. Okay? Or changing, or variable. Now, constant just means it is not changing. Another word for constant that might ring a bell, for those that have heard this before, is the word static. Okay? The word static means the same thing. It means not changing. Static and dynamic in engineering are terms where static, engineers who work in statics are traditionally civil engineers, because they work in making buildings. Do buildings move? Or are they supposed to move? No. Whereas mechanical engineers work on things like rotational mechanics, like a car tire. Isn't a car tire always moving? Yeah. That's dynamic. Okay? So you see constant functions all over the place, whether you realize it or not. Okay? If you think about something as simple as the metro fare in the morning every day at the same time. Okay? It's not going to change unless what day of the week will it change on? Saturday. It might change on Saturday or Sunday.
It changes during the day.
But at the same time, though, I'm saying. During the day, absolutely, because you have the peak hours, the non-peak hours, of course. But if you get on every day, every morning of the week at 6 a.m. and take the same ride, it's not going to change, right? It's a constant fare every day. That's a constant, right? Now, that's our first type of function. Our second type of function. We've seen this before. And again, I can write f of x, I can write g of x, I could just write a y. Same thing. If I have something like 2x plus 3, what's that?
You say you go write gfx or whatever, or I could just write a y. How do you go from one to that, like, gfx to a y? Like, you make it so simple.
Because what did we define earlier? We said that f of x is the same thing as y, right?
Yeah.
So in the first example, I used f of x. Now I'm using a different example, I'm calling it y instead. The next one I'll call it g of x. But they all mean the same thing. They all mean this is a function of this. This is a function of this. So the function here is 5. How do I define that function? I chose f of x. Here I'm choosing y. It does not matter, okay? What is this called from last year in Algebra 1? What kind of a shape is this named, or what kind of a thing?
What?
Shape.
U. That's a slope. That's a slope.
Okay, what is this called? What is the figure called? What is the graph called? It's called a what? Linear or line. It's not a trick question, guys. Okay? It is linear or a line. So here, we're talking about linear functions. Okay, linear functions. Now, what do we know about the values of the linear functions?
They're, one of them are constant, one of them are constant.
Okay? So, this value, what does this represent, the 3?
The beginning point, the y.
The y what?
Y axis, y point.
The y intersects.
The y
Intersect.
intersect. Very good. The y, you guys help each other. The y and the intersect. Good. Now, what does this 2 represent?
Slope.
The slope, or the rise over the run. We're going to spend some time looking at linear functions. So today we're not going to go into crazy detail, but
Yes.
again, this is a linear function because it makes a line. The simplest way,
So what's the,
this is the y-intercept, this is the slope. Okay, but again, we're not going into linear functions just yet, we're just defining them right now. So here, if we take a look at this one, we will see that in this example, our function is changing. And we can graphically represent that with a line. Okay, where the y-intercept is 3 and the slope is up 2 over 1. And again, that's just a sketch for now. You just kind of pick up on that after a while. Okay? I do enough of it, trust me. Now, if I were to pick a value of x, like 2, how do I find the y value?
You work out the
Good. So if I did that, and I picked the value for x of 2, Marcus, what is the y value going to be?
Oh, gonna be 7, no, 4, 7, yes.
Very good. Again, 2 times 2 is 4, plus 3 is 7. Okay, so this is no different than the other function. You want to find the height of the function? Here is the height of the function. Here is the location. So at the point 2, which is here, the height of the function is 7. Again, this is the location on the x-axis, or the width. This is the height, or the location along the y-axis. Okay, again, we call this the height because it's going up. We can also call this the value of the function. The value of the function, yes?
How do you get 2 times 2?
I plugged in this 2 right there for x, because this is my x value. 2 by 2 is 4, plus the 3 gives me the 7. Whenever I want to know the height of the y value, Jose, I take the x, I plug it in wherever I see an x, and I evaluate what the answer is. I then perform my operations. 2 times 2, and then plus 3. Make sense? Sort of? Do this in Algebra 1. You gotta think back. I know it's a while ago. But again, all we're doing is plugging in the x, and we're plugging it in here. We see a 2 times a 2. That gives me a 4, plus that 3 gives me that 7. Rosie.
So it will always match. I mean, no.
I know, you know stuff. Say always what?
Will it always match?
What do you mean by match?
Like the graph?
Yes, so this graph is, the graph that I just sketched is created by the points that we would plug in. For example, if you plugged in a 0 for x, you would get a 3. That's this point right here. Again, I just sketched it though. So if you wanted to really graph this the right way, you can make a table of values. That's always one way to graph something. Okay? That's our linear function. Next, if we have something like g of x now. Again, it does not matter what I call it. It just means some function of x. Okay, some function of x. Now, take a look at this one. What do we call this? Does anybody remember?
It's like
Quadratic. Quadratic because of this x squared right here. This is a quadratic function. Now, the shape of this is called a parabola. The function is called quadratic, but the shape is called a parabola. And we will go into this when we talk about parabolas. That's not until concept 20. Okay, well, we need to know these terms. So it's a quadratic function or a parabola. Again, if I wanted to find out the height of the function at a given x value, if I said, what is the height of this function when x is 3? What do I do with the 3, guys? Just plug it on in.
Oh my goodness.
well,
Every time we say that, Melody, you got to say that, all right? For now on, every time we say plug it in, I want to hear that.
I'll get you a job.
3 squared is 9. 9 plus 12 is 21. 21 minus 1 is 20. So this tells me that the height of the function is 20 when x is 3. Again, the value of the function, or the height of the function, is 20 when x is 3. How did we get this? We took the 3, we plugged it in here, we simplified, and got our answer out.
How did you get the 3?
I picked the value. Again, the question has to ask you what x is. You cannot, if you're not given x or y, you can't do anything, right? So the question has to say, find the height of the function when x is 2. That tells you that x is 2. You plug the 2 in, and then you find your corresponding height.
So if we don't have
And you
that,
can't do
what do
anything
you think?
else. Later on, if we talk about graphing, we'll talk about how you can choose points to use here, and it will help you and stuff. But for these kinds of functions, there are problems where it's asking like, what is the value of the function? Or what is the height of the function? Or evaluate the function at x equals 7. Put a 7 in, get a value out. Okay? So the question is going to ask you the x value, you determine the y. Now, it might also ask you the y value and say what x value causes this y value. So if a problem said, for example, let's try, if we had, let's go to the last one to make it a little easier. We'll go back to this one. If I told you that the y value here was 13, I said to you, where on this function is the height 13? Where is the function when the height is 13? What am I asking it for? I'm asking you for the x value because I'm telling you the height is 13. So the height goes right here. So if I tell you where on this function is the height 13, what can I do, Rosie? Subtract 3.
And then it would be
13 and y.
Good. Very good. Now, just to make a statement, let's say we set it equal first. Is that okay? And then we subtract the 3. But we know, I understand what you're saying. The height of the function is 13, so we put the 13 in for the height. We then subtract 3. We divide by 2.
Hold on, you put 2y.
And it's an x. Thank you. Thank you, Marcus. So what does that tell us about our answer? The location is 5 when the height is 13. So you can work in either direction. Okay? Finally, let's go to the last type. Anything above squared, we usually just call polynomial functions. You can call x to the third a cubic function if you would like. So if you see okay, we can call this cubic because it's to the cube or to the third power there. The highest exponent is 3. 3 is cubed, so you can call that cubic. Now, anything from 3 and beyond you could actually just call polynomial. Poly means what again? Many. Many, okay? So we have many different degrees here, or many terms. It's a higher term, or higher order. So let's look at one like, so here, what's the highest degree or highest exponent going to be here?
4.
The highest exponent? 5. Again, what is the exponent itself, guys? Be careful. 5. So we call this one a polynomial. Okay? Please don't be misled by the beginning. A lot of people see the beginning and they say, oh, it's a line, 3x plus 1, and they just ignore this part over here. Well, this part is what determines the name of it, actually. You need to look for the highest exponent to see what the name would be.
So we have to find the name.
So we have to find the name too? Yeah.
You should know the names. By the end of the year, you will know the names. I'll tell you that right now. Trust me, you will know the names of all these by the end of the year. I'm giving you the names now, though. Okay? All right, so let's get into the real beef of today's lesson. Okay? That was just the topics right there. Let's get into the actual meat of it. So, let's look at the first example. Using direct substitution, find, let's use the word evaluate instead of find. Evaluate f of x equals. These are the kind of problems that you'll see on the SAT, guys. You okay, Carol? Okay, please read through the question. Make sure you understand what is being asked. These problems are not difficult, but sometimes the wording can confuse some people.
3x plus 2x.
Rose, was 2.
Again, using direct substitution, evaluate the function when x equals 2. So, Jordan, tell me, what are they asking us to do here, Jordan?
Into
Rose, you want to explain what?
No, Jordan.
You can do it, come on.
Alright, so you know that our biggest exponent would be 4.
Okay.
oh.
Well, what is the problem asking us to do?
What do you guys like was it?
Let him go through
Fill
this.
in x
With?
2.
Good. Again, All you're asked to do here is put a 2 in for x. So what are we doing? We're doing this. Take a look. We're finding f of 2. This here, please take a look, everybody. This is not f times 2. This means the function when x is 2. Just like we said up here, when x is 2. What does that mean? We just plug in. Again.
Hold on. When you got the exponent, you just multiply like 3 times 2 times 4.
Yeah.
So, here, think of PEMDAS, Marcus. PEMDAS tells us to do parentheses, then exponents. So I've got to do the exponent first, and then multiply it by 3. So please, please write this down if you didn't know that. This has to get done first. This has to get done first, and then you can multiply by the coefficient. Many people mess that up. It's a good question. Thank you for asking.
So can't you remember, please excuse my name?
Yes, PEMDAS, same thing.
But
So acronym.
easier way.
Dad.
That's fine. If that helps you use that. I think PEMDAS is easier because it's one word.
Hold on.
I don't have to remember 6 words.
I think because
It looks like it's gonna be the same thing.
I remember it.
There's so many for that. Have you heard of other ones?
Here's how.
Dad.
Here's how.
Yes, Marcus.
So it's gonna be 2 times 4. 4 times
So here we're going to have 3. Now what is 2 to the 4th? That means 2 times 2 times 2 times 2.
2 times 6, 4. 4 times 2 is 8. 8 times 8.
Should be good. 16.
Times 3. 43. 43.
Again, take a look. Make sure this makes sense. 2 to the 4th is 16. That's where that comes from. 2 to the 2nd is the 4 right here. The rest I just carried down. Now multiply. You're going to get 48 plus 8 minus 10 plus 7. Again, just combine your like terms at this point. Just combine your like terms. If you're doing this in your head, just go from left to right. Do 48 plus 8 is 56. 56 minus 10 is 46. 46 plus 7 is 53. Very
I don't know
good.
why I'm doing this. I just like to do it.
Okay? Personally, if you want my opinion, I would not use a calculator here. It probably takes longer to type that in than for me to do it in my head. Okay? And once you start practicing this kind of stuff enough, it will take you less time just to quickly do it in your head.
So what is 53 equal?
That's the next question I was going to ask, Rosie. Thank you for asking.
That equals 1.
What does 53 mean? The y value. Again, remember what we said at the beginning. F of x is the same thing as y. This here means y. So this tells us that when x is 2, y is 53. So what have we determined? We've determined a point on the graph.
Oh.
Again, we plugged in, I know, crazy, right? If we made the table, just to find the y value, we put a 2, we have to do all this work to get it. Now, we'll talk about tables later, and I can do that on calculator. How about you?
No, that wasn't.
The call for a sneeze.
It was a sneeze.
Okay.
But, you know,
That was a
let's make it
sneeze?
up. Yeah.
That was not loud.
So again, this here, this 2 is what tells us the x value. The 53 down here tells us the y value. So, tell me, what is the height of the function here?
53.
Good. At what location? Very good. Again, the height is 53, or the y value, or the value of the function is 53 when x is 2, or at the location of x equals 2. Again, we're doing the same thing every time right now, so it's not going to change anything. Let's move on to a second one.
You should be
Can
asking about worksheet. I think we'll have to,
Okay, you don't know a lot of
Just homework worksheets, yeah.
Think of it.
Honestly, Rosie, I only give out ones for homework because we do so much in class that there's no time for class worksheets right now. But usually I think we do pretty well doing this together. Okay, let's word this a little bit differently now.
As long as you pay me good money.
No.
That hurt.
be the name.
That's what you wanted.
Is that U a function of what?
Very good.
I thought that was and.
Again.
at first.
What's
It's
up with
find the
that?
height of u of y now. Keep in mind, we talked about f of x, g of x. Now we're doing u of y. So my quote-unquote x value is now called y. Do you guys see that? Again, this is now the height. This is now the width. Relax, relax, relax. All we did was change up the letter. And you need to remember that the function itself is called the height, and the independent variable is called the width. Here now, the independent variable is y. It can take on any letter. You cannot let that confuse you. Again, they can be any letter. The notation does not matter here. Yes, Jordan.
Working with the, U is on the and, we were working with the language,
Say it one more time.
right? U. It's-
Oh, yeah, that's the capital U. That means the setup. That's completely different.
Oh, okay. So
This is just the
location
variable
U.
U. Yeah,
So you're gonna give us a
So the
Y.
capital U moved on the big one.
yeah. So, good. You're given y. Very good, Rosie. What is y in this case? What is it told? -3. And what am I asking you to find?
The height.
The height, which is which variable?
You.
The u.
Which would
Again.
be the x.
Remember, last problem, the y, we were talking about the height. Keep in mind, though, for this one, what this is asking is to say find u of -3. That's what this problem is.
Basically, it's like find x.
Find when x is -3. Sure, you can think about it that way. This is like your x value. But I don't want you to think of just x.
Why? This is so
No, x, not y, x.
What?
Why?
Someone
You
get
did it.
annoyed! You're so crazy!
You got it, Jordan? No.
Used it yesterday.
You like how I ignore you, Kara? The whistling?
That's what my dad used to do.
I've heard it back there, don't worry. That keeps you entertained, that's fine, man. Alright.
81 and then.
Now, we have to plug in. Be careful, people. Be very careful here. Immediately, please, plug in the value. Now, before you all go to your calculator, let's discuss this, because many people make mistakes on their calculator here. First, look over here at the -3 squared. What is a negative squared going to become? A positive. So does everybody understand how this line here should be a 2 times 9? Everybody agree with that?
Yeah.
Again, this is a negative number. When you square it, it becomes positive. If you enter it in your calculator without the parentheses, it'll show you a negative answer. That is not right. The parentheses are extremely important. You are squaring -3. If you simply write in your calculator, and don't write this down, please. If you write this in your calculator, it will do the opposite of 3 squared. So it will do 3 squared as 9, and then apply an opposite sign to it.
Calculator for retarded.
Okay? So you need to use your brain here, not your calculator. Next. If I had -3 cubed, though, -3 cubed is -3 times -3, which is 9, and then times another -3,
That's negative.
-27. So here I'm going to have still carry down the -3. This will be -27. I'm putting parentheses around it only because I didn't want to put the dot with the subtraction sign also.
I do -27.
-3 times -3 times -3. Remember though, here's the trick, guys, if you didn't know this
The
already.
number is positive and opposite are negative.
Very good, Claudia. As Claudia just said, when the exponent is even, you're going to have a positive number no matter what. When the exponent is odd and there's a negative, it remains negative. So if this was a 3, or a 5, or a 7, or a 9, it stays negative. 2, 4, 6, 8 as exponents, those become positive. So here, very good, this is going to be 81. You should.
Just be a lawyer.
You're pretty good. And now again, we're taking the -3 and we're putting it to the 4th power. It's -3 times -3 is 9, times -3 is 27, times -3 is positive 81. Okay? Again, be careful. Now at this point, what do? Minus what, Rosie, or plus what? What is it?
Negative 81.
Positive, right? Negative, negative?
Oh, okay.
Be careful.
Plus 18 minus.
Again, please be careful. Here, you have a negative times another negative. That yields a positive. Again, negative, negative, positive. At this point, combine your like terms, please.
This isn't that hard. It's just
A lot of work.
the first
It's
part.
a lot of plugging.
Finding out what the question is asking is usually the hardest part of these problems.
That's all it is.
And then after that, don't make silly mistakes.
You see, I make all the stupid, silly mistakes. How do you spend that?
Well, you can fix those, right? How do you fix them?
No, it's just like, it's just finding out what they're looking for. And the yield,
Excuses.
Rough life.
excuses.
243, 253, 261, 257.
Mr. Howell, what they will be looking at.
Does that sound good, Rosie?
Yeah.
You didn't even look this up.
I know.
Now, what does this tell me about the final answer? Here's what it tells me. When we're looking at the point -3, the function has a height of 257. Again, when we're looking at the point -3, the function has a height of 257. So if I made a table now, my table is y and u of y. And this is -3. When I put that input in, my output is 257. Again, what is the input? The input is whatever you're given to put in here. The output is your 257. So this is like my width, meaning I'm going to the left on the x-axis or the horizontal
Why do
axis.
you put Y?
Because what was the function defined as? Was it defined as f of x?
No.
It was defined as u of y, right?
Yeah.
And remember earlier when there was an x here, the x went over here?
Yeah.
But now there's a y there. So what should go here?
Y.
Whatever is the independent variable
But
is your
on-
input.
But on the little graph thingy, that would count as the x-axis.
Correct. That's why we haven't remember I said don't call the x-axis, I said call it the horizontal axis. For that reason. Because, take a look, if we were to graph this, it's going to be at -3, 257.
Okay.
That's where the location of the point is. Okay, that's a good question, Robbie. Again, the names don't matter here. X of t, y of x, u of w. It doesn't matter what the function is called. What matters is that you know you have a height, you have a width, or an output and an input, or a vertical axis and a horizontal axis, or a dependent and an independent. There are so many ways we can describe this without using y and x. You don't have to use those letters. Let's continue on to another one, please. All right, let's take a look at an example that we can apply to sports here. So, let's say we've got a baseball. Okay, the flight, we're looking at the flight of a baseball here. Now, as you know, think about a baseball. A person is standing here. Okay, they've got a bat in their hand. The person swings the bat, hits the ball comes in, and the ball will go off, you know. If you hit a line drive, we're probably happy, right? But let's say, for the sake of this argument, that the person hit the ball, and they hit the ball at a 20-degree angle. So they got a little bit of loft under it. Okay, the person maybe is swinging for the fences here. And the question is this. The question is to find out where the ball is at 1 second, given the function. I'm going to give you the function, find where the ball is, what the height of the ball is, when you have 1 second gone by. So the function is defined as the following. Okay, there is SOHCAHTOA here. Let me just put this as theta for now. Okay, you're not actually going to have to use SOHCAHTOA here, though, because you can just plug it in your calculator for this one. Now, here's what you're given. You are given that the speed or the velocity of the ball when it exits the bat is 55 meters, or let's say, yeah, meters per second. Okay, so the ball is hit at 55 meters per second. We are also told the angle is 20 degrees.
What is that?
Okay, again, what does this symbol represent, guys? Geometry. Last year, what was it called?
We didn't learn that.
What did Mr. Malachek call angles?
We use a little angle thing.
You didn't call this theta?
No. We didn't.
Okay, no big deal. So, in math, symbols like theta, beta, and alpha are used to indicate angle measures. Okay? So this theta here is representing the angle that the ball was hit at. Okay? This is one of our Greek symbols, yes.
What is that? What is that?
It's a circle with a line that is not horizontal, but it has a slight incline to it. Okay? And it is pronounced, by the way, I'll tell you a quick story. When my teacher taught me this in geometry, the whole year I thought she was saying theta, like feta cheese, F-E-T-A. And in my notes, I kept writing F-E-T-A. On the final exam, she happens to write a question and writes, what is the value of theta? And spells out the word instead of putting the symbol. And I had no idea what was going on. And I'm like, I liked math, you guys know that. And it was the only problem I couldn't figure out. I was sitting there losing my mind. Finally raised my hand. I said, I remember Miss Carpenter. I said, Miss Carpenter, what is this theta? Like, she's like, Mark, you've done the whole test, you don't know what theta is? And I'm like, I've never heard of this. And she's like, if you know the angle. I'm like, you mean theta, right? She goes, no, theta. And she's like, you thought it was a cheese all year? And I sat there and I was like, yeah, I thought it was a cheese. But it's theta, it's not theta. Okay? So again, theta with a TH. Haha. Thank you. Okay, now, knowing those values, let's plug in. So we have sine of 20 degrees times 55 times t plus. Now, we need to plug in what t is time. Remember, t was our time. A stands for acceleration due to gravity. Okay, and it's something you don't have to have memorized. But if you happen to know it from physical science, the value is negative 9.81.
Oh, wow.
Okay? The value is negative 9.81. It's the acceleration due to gravity on Earth. That's what that represents. Okay? The acceleration due to gravity on Earth.
Do you have time to explain that?
I can, but let's continue this problem first. If we have time at the end, I definitely will. Okay? Now, the problem said to find the height of the function or find the height of the ball after 1 second. So what do I plug in for t?
1 second.
Just 1. Very good. Or 1 second. Very good. So right now I'm saying, what is the value of y of 1? Which means I'm pretty much just doing the whole function with a 1 in for t. So if I put a 1 in for t, I'm going to end up with sine of 20 times 55. Do I have to put a 1 here, really?
No.
Good. I don't have to put a 1. Plus negative 9.81 all over 2. Why don't I need to put a 1 anywhere? Because does 1 do anything when I multiply?
No.
No, it does not. Okay? If you do this, you end up getting...
It's like chemistry. Like we do it in chemistry.
Did I do it right? No.
Check your mode, Rosie. Hit mode. Okay? Is radian or is degree highlighted?
Radiant.
Go to degree, highlight degree, hit enter. Then go back and type in the same thing. Press second enter to run the whole thing through again. And you'll get 13.91. Because we are in degree mode. And we'll talk about that toward the end of the year. Again, so after 1 second, the ball has a height of 13.91 meters. That's approximately 40 feet. Okay? So this ball, it could be on its way up on the path, right? It could be like here maybe at 40 feet. Or it's not at the max height maybe. Where's another 40 feet? Isn't this also like 40 feet? So we don't know, as of right now, without using physics, we don't know if the ball is on the way up or on the way down. We really don't know. But we do know the height of the ball is 13.91. Okay? Let's do one more example, and then I'll try and get to your question about acceleration. The last example. Let's go over something like texting, okay? So imagine you're looking at your text messages. Let's say, theoretically, every month, what do you guys pay? What do you pay like for your data plan? You pay a flat fee every month, right? So say it's like $20 a month to get data, or $30 a month to get your internet on your phone.
Oh, yeah, 30.
So every month, here's how it works. The cost function for text messages is defined by the following. Now, the $15 in the beginning, this represents the initial fee that you pay every month. Okay, no matter what, every month you pay $15 to have texting. But let's make believe that you have a limit of texts. And every month, your limit is 500 text messages.
That's a bad one.
Okay, for you guys, I know it is. I mean, every month.
That's like a big one.
So your text messages, your limit is 500. Now, every text you go over is what n represents. So n is equal to the overage texts.
Maybe try to slice it.
Okay? So n is representing the overage of the text. C of n is the cost per month. Now, let's say, for example, Olin, this month you sent 650 texts. How much did Olin go over by? 150. Again, Owen sent 650 texts this month. N is not 650. N is the number of overage. So if we want to find N, we take the 650 that he sent, we subtract the limit that he can have, and tells us that he went over by 150 texts. Okay? It was given. Again, say you texted 650. So that's your X value, or your independent variable that you're plugging in. You know how the whole time we've been plugging in numbers? We're given the 650. We have to then subtract the 500. Now, if that's N, and I want to know the cost, I have to say the cost when N is 150. Again, what is the cost of your monthly bill when N is 150? And what you will notice is this: if you plug in a 15 plus 0.15 times 150, you will end up with 37, God bless you, 50 for that month. Okay? So it tells us that this month, instead of being $15 a month, because you went over by 150 texts, your bill is $37. Now, this is not realistic because everybody will be paying out the wazoo for this, right? Now, overage texts are usually more, by the way, if you have a limit. When I was younger, first, this is a 0.15, 150, 15. When I was younger, there was like, everybody had a limit on texting. There was no such thing as unlimited texting. And when the first time I got a phone, and it was freshman year of college, okay? So, my younger brother went over 1 month by like 200 texts. And texts were 40 cents a text over. Not 15 cents a text, 40 cents a text. So we had to pay, like, you had to pay an additional $20 that month. The next month, he went over by like 6,000 texts or something ridiculous. Our bill was like $400 that month instead of being like $100.
Did you take away his phone?
My mom eventually did, yes. After the first try, she gave him a slap on the wrist kind of thing. The second time, it was like, the phone's gone. But again, this is real life stuff, okay? This actually can happen. Now, again, you guys know text now you have unlimited, so it doesn't matter, right? But in general, you can have this. Quickly, to answer your question, Jordan, you asked about gravity, right? Okay. So, if you guys remember from physical science last year, or 2 years ago, rather, in physical science, you have Newton's 3 laws, right? An object in motion will stay in motion unless acted upon by an outside force, also called inertia. You have equal and opposite reactions, and then you have the third law, which was F equals ma. Okay? A was acceleration, m is mass, F is the force. The way gravity works is you are currently being pulled down to the center of the earth at all times. So gravity is pulling you down. If I were to drop any given object, the rate at which this falls, or the rate at which it accelerates, is that value from the last problem, negative 9.81, meaning it's accelerating down, which is where the negative comes in, and every single second, it gains speed by another 9. So in the beginning, there's no speed when I drop it. But after 1 second, this object had now picked up 9.81 meters per second. So it's getting faster and faster. And that's the idea of like sky jumping, or bungee jumping, or skydiving. When you skydive, if you don't pull a parachute, what's going to happen? You're going to get faster and faster and faster until you hit the earth, which is not good, obviously. So you pull the parachute, the force of its like buoyancy in a sense, it counteracts the weight pulling you down, and that's why you float down slowly. So the force pulling you down is gravity. That's where this number comes from. You pull a parachute, now that force suspends you in the air and slows you down on the way down. Okay, if you want to know more about this stuff, sign up for physics next year. Okay? Your homework tonight will be to complete this worksheet. The first 3 are very simple. They are plug and chug. Plug in the number. I want to see what the height is. Number 4 and 5 are word problems. Make sure you understand those. Those are the ones that you're going to see more often on your SAT. Okay, numbers 4 and 5. Take one each. Please don't leave yet. You can leave as soon as you get it. Go ahead. If you need to make stuff up, start doing it. Start putting your name on the board and showing up. Again, put down the day you're going to make it up and the concept you want over there.
Oh my gosh. Oh man, you're excited. You have a heart attack.
That's another room. I don't know which one, man.